Okay, so in this simple circuit we are going to do transient analysis. That is, we are going to find voltage and current in different time, and to do this we have to go setup analysis, then transient, and here in the final time we have to set let's say we have set 100 millisecond. That is, we are going to find the information from 0 to 100 millisecond. Okay, then we run the simulation and we will see that at the x-axis the time has already fixed from 0 to 100 millisecond. Now to set the y-axis, let's say we are going to find the current. To find the current of the circuit, let's pick the current marker and place it just right before the capacitor. Okay, now you don't need to run the simulation again. Just go to the plot and you will see that the y-axis is set to the in y-axis the current has been set, but you are not getting a clear transient part. To do this, we have to decrease the final time. Let's say we decrease the final time to 1 millisecond, and then we will get a transient part. You can see the current is decreasing. If I decrease the final time again to 0.1 millisecond, then we will have a clear visualization of this transient part. And if you want to see the informations of different point, go to here, toggle cursor, click here, and you can see the voltage time versus voltage. Here 8.2114 microsecond is the x-axis information, and 440.258 millivolt, it is the information of y-axis. Sorry, it's current, 440.25 milliampere. And now if you want to you can click here, then press the keyboard's delete button, then it will go away. Now if you want to check the voltage, of this capacitor, so to do this, go to markers, then mark voltage differential, one put here and another here. Then if you run the simulation again, so you will see the voltage that is increasing up to 10 volt. Okay, now you can set the y-axis in different way. And how you can do this, you can go to the address, then if you want to find the voltage, you can go here. Let's say you pick the voltage of this, and if you want to see the current, go to current and pick the current. And even if you want to see the power dissipated across the capacitor, then click here and then press OK. So in the same plot you will have three different graphs in the same plot. Now if you want to do some more transient analysis with V sine, okay, input here V sine, then V of it must be always 0. Sorry, it's offset voltage. Actually it might be 1 volt, 2 volt, or anything you want. B amplitude, let's say 10 volt, and frequency, let's say 50 hertz. Okay, then setup analysis, transient analysis, I put it to 100 millisecond. Okay, then if I click here, if I want to see the current, you will see that the current is distorted. That means the graph is not smooth. To make the graph smooth, you will go to the schematics, then again this transient. You can find here the step ceiling. You will add here, if you add here 1 microsecond, then it will print the data after 1 microsecond, step by step. So you will get a clear data. Let's see, if you run the simulation, it is taking time, but it will give you a clear and smooth graph. Okay, it gives you a clear and smooth graph, right? And again click here, toggle cursor, you can see it's the sinusoidal graph. To go to the maximum point, click here, then you will go the cursor peak, then you will go to the maximum point here, and if you press here, you will see the information, x and y coordinates information here. And if you want to go to the minimum of this graph, click here, then press here, and you will see the x and y coordinate, that is time versus current coordinate here. And if you don't want to start the time from 0 second, if you want, let's say you want to do a transient analysis from 30 millisecond, okay, that is you have to delay from 0 to 30 millisecond, that is you have to delay 30 millisecond, and after the delay you will do the analysis. To do this, again go to the schematics, transient, and you can see here the number of print delay. So click here 30 millisecond. So if you write here 30 millisecond, then it will delay 30 millisecond, and after 30 millisecond it will show the graph up to 100 millisecond. Then you will get the information from 30 millisecond to 100 millisecond. Okay, oh sorry, 30 millisecond. Then if you run the simulation again, you will see that the graph, that the time starts from 30 millisecond and ends at 100 millisecond. Okay, and if you are bothered with the time, so you can go here, transient, then increase the step ceiling. Let's say you want to print the data after 10 milliseconds step by step, so now it will take less time. See, it takes less time, and you have obtained the graph like this. And again, if you want to find the inflection point, you can press here, and see you have find an inflection point here. And so that's all for today.